So we now know how to find out if we have a factor, and we learned how to factor. But the problem is, what if I give you a problem like this and I tell you just go factor it? You can't, because you don't even know where to start. You don't even know what you should be dividing by. What are we supposed to be checking out? Well, what I'm going to give you now is the steps for finding possible zeros, potential zeros. Only all of the ones I'm going to show you how to find are rational. We might have answers that are not rational later, but right now, all I'm going to do is show you how to find potential zeros that are actually rational. The first thing that I need you to do is I need you to factor the constant of your polynomial. So in my example right here, the constant is negative 12. And we're going to call those factors P. It's just so that we can call them, instead of saying the factors of the constant, we can say what are your P values? And that would be factors of this right here, listing the potential zeros. The P values would be 1 and 12, 2 and 6, 3 and 4. Because the factors of 12 are 1, 2, 3, 4, 6, and 12. Now don't forget that that's a negative number, so we have to remember that positive or negative could be the roots. And so we're going to call plus or minus P values. The second step is to factor the leading coefficient. We're going to factor the leading coefficient, and we're going to call that Q, and we're going to do plus or minus Q. Well, in my problem that was the sample here, the leading coefficient is 3. Well, the factors of 3 are 1 and 3. The last step is really very simple. We divide P divided by Q. Now, it always has to be in that order. You never divide Q by P. It's always P divided by Q. So when I'm working through this, I know that 1 divided by 1, my P over Q values, which is my potential zeros, is 1 divided by 1, 2 divided by 1, so forth and so on, 3, 4, 6, and 12, all divided by 1. But now I have to consider that 1 could be divided by 3, which means that 1/3 is a possible zero. 2/3 is a possible zero. 3/3 is 1. We don't write that down again. 4/3 is a possible zero. 6/3 is 2. And 12/3 is 4, so we don't write those down. So all of my possible zeros are right here. To determine the real zeros, we're going to list the potential zeros and test each one by either plugging them into the equation or doing synthetic division and seeing if the remainder is 0. There's one more shortcut that I'm going to allow you to use, which is really incredibly useful now that you have a tool available to you. You look at this problem right here. You put it into your graphing calculator. Once you have put it into your graphing calculator, look at the table of values. And you don't have to look everywhere. You just look next to the number 1 and -1. 2 and -2, 3 and -3, and so on, and check and see if you get a 0 for the y value. If you get a 0 for the y value, you have a root that is a 0. Now, how do I check fractions? When I look at the table of values, all I see in the table of values is whole numbers. So look right here. When I look at my table of values, all I can see is whole numbers. Now I've already found one right there. Can you actually, when I scroll up, I find one right there. -1 works. Can you see that? Because it has a 0 next to it. Let me zoom in a little closer. -1 has a 0. So I know I found at least one factor. But what about these fractions? What if I wanted to try 1/3? 1/3 doesn't show up. So on your calculator, there is a button called Table Set. It's actually called Window, but the blue above it says Table Set. So you hit blue second, Table Set, and you tell it, hey, I want to start at 1/3. And you look at the table of values. And 1/3 did not give me a 0, but 4/3 does. And how do I know that's 4/3? Because I know that this is 1 plus a third, so 4/3 is another 0. So going back to my problem, I know that 1 is a 0. I know that 4/3 is a 0. And I've also discovered that -3 is a 0. I know all the zeros. So how could I write this in factored form? Well, x equals 1 makes a factor of x minus 1. X equals 4/3 makes a factor of x minus 4/3. And x equals -3 makes a factor of x minus 3. So I'm looking through this problem and I think, okay, I've got x minus 1 times x minus 4/3 times x minus 3. If I multiplied those together, I should get this problem, but I won't. And the reason that I don't is x times x times x is x cubed. What's missing? From that first term, I'm supposed to have 3x cubed. So I'm going to multiply the whole thing by 3, and we have put it into factored form. Now, a lot of people don't like fractions right here. So what I'm telling you is anytime you have a term with a fraction in it, you are allowed to multiply that 3 in the front times your term with the fraction, making this x minus 1, and I'm going to distribute here, and that's going to give me 3x minus 4 times x minus 3. Now when I multiply all those together, notice this is still going to come out to 4/3, which is a root, and when I multiply all these together, it will be exactly the same as this problem right here.